Guys, can you hear me?
Yes, ma'am.
Okay. See guys, these are the solution. These are the contents. Okay. So according to your request, we will go through the topics. Okay. Tell me, what about real numbers? Do you want to see real numbers?
No, ma'am.
Okay. Then what about polynomials?
No, ma'am.
Okay. Then next, pair of linear equations in two variables?
No, ma'am.
No. Quadratic equations?
No, ma'am.
Arithmetic progression?
No.
No or yes?
No, ma'am.
Okay. Triangles?
Yeah.
Okay. Coordinate geometry?
Yes.
Yes, we will see. Yes. Okay. Introduction to geometry. What about introduction? That we have seen, but do you need to see some challenging questions?
Yes, ma'am.
Okay. Then some applications of trigonometry?
Yes, ma'am.
Okay. What about circles?
No, ma'am.
Constructions?
No, ma'am. Yes, ma'am.
Okay. Areas related to circles?
Yes, ma'am.
Surface areas and volumes?
Ma'am.
Statistics and probability?
Ma'am.
Yes, both are, you need both. Okay, we will see one by one in order. Okay, now we will see triangles. Already we have seen triangles, but shall we see some tricky sums? We just discussed, okay? Okay then. Page number 143, but here it will be different, I guess. Huh? Okay. See, in the year 9, you would have studied congruent figures, isn't it? Okay. So we will see in this chapter, we will see similarity and congruity. Both the concepts we are going to discuss. Okay. Tell me, what are the criteria are there for similarity?
Yes.
Hmm? Wait. Yes, wait a second. Yes, you are right. These are the properties, are there? 1 second. I shared. Okay. Okay. Now we will discuss what is the difference between similarity and congruency. Anyone?
Ma'am, in congruent, length equal. In similar, side are different.
Mm. Okay, I'll show you. I'll show you. 1 second. So this is similarity. You see, if you see this figure, there are two triangles. The two triangles, they look similar, but they are not equal in measures. The three side measures of one triangle is not matching with the three triangles of another triangle. Okay, so this kind of figures are called similar. Okay, I want a different. Similarity examples in real life. See, this is I think you will understand better. Something is coming. What I want, except that one. Okay. So this is called similarity. The figures exactly they are matching, but the sizes are different, isn't it? They are different in size. So this kind of figures are called, this is example for similarity. Okay, that's it. Congruency. I'll show you what is congruent figures. So this is an example for congruency. Both the figures are exactly look alike. So these kind of figures are called congruent. But in case of triangles, see, on seeing the real life figures, we can easily say this is similar, this is congruent, like that. But in case of triangles, we have certain criteria to fix whether they are congruent or similarity or not. Okay, tell me what are the similarity criteria? Congruency criteria you would have studied in 9th standard. Tell me what are the congruency criteria. First, we will discuss with congruency, then we will come to similarity. Criteria, tell me.
RHS.
RHS, okay. Okay. RHS. RHS, okay. Then yes. And yes, and yes. Okay. See, RHS means in a two right angle triangle, hypotenuse, and any one of the side or matching. Then yes. All the three sides of two triangles are matching with each other. Okay, three measures of the three triangles are matching with three sides of the other triangle. Then yes. Side, angle, side. See, you must notice side, angle, side. If it comes like this, side and this side and this angle means this is wrong. Okay. See, that angle must be inclusive between the equal sides. Then only it is accepted. Side angle, side. This way it should come. Otherwise, it will not be accepted. And angle, side, angle. Okay. So similarly, the same case, this also angle, angle, and side. It will not be accepted. Okay. It should be, the side should be included side between the angles. Then only it will be accepted. This should be angle, side, angle, angle, side, angle. Okay, then only it will be accepted. Make a note of these criteria. I will give you the list of similarity criteria. So there are 5 criteria for similarity. Same way, 2 triangles are there. You draw the figure and show it in the figure. Okay? Without drawing, don't do anything. Right angle, hypotenuse, and any one side. And AA. Angle, angle. Obviously, if 2 angles are matching, obviously the third angle must be matching, isn't it? Okay. Then this one. Angle, side, okay, side, angle, side, side, angle, side. Okay, this one. Angle, side, angle. This is angle, angle, side. Angle, angle, side. Okay. So make a note of it. We will move to next. Copied? Once you copied, let me know. Okay. Okay, next concept we are going to see basic proportionality theorem. That we can say BPT or Thales theorem. Have you ever heard this one?
Yes, ma'am.
Okay, what the theorem says? Tell me.
Straight line drawn parallel to the side of a triangle divides the side between the two sides.
We will see. So this is the theorem. What theorem is saying? if a line is drawn parallel to one side of a triangle. First, we draw a triangle. There is a triangle. Okay. If a line is drawn one side of a triangle parallel to, if a line is drawn parallel to one side of a triangle, so the line parallel to one side of the triangle, intersecting other two sides in distinct points. So first I name the vertices of the triangle ABC and EFC. What is given in triangle ABC? EF is a line parallel to BC, intersecting AB and AC at E and F respectively, isn't it? Respectively. Then the other two sides are divided in the same ratio. What does it mean? Which implies AE by EB is equal to AF by FC. Okay, this is what they are saying. If this line is parallel to, F is parallel, one of the line, a line is drawn parallel to one of the sides of the triangle, then the ratio of the other two sides will be equal. This is called basic proportionality theorem. Okay, shall we see how to prove this theorem? Guys, do you know, or shall I explain how to prove this one?
We know.
You know, no need to explain this.
Yes, ma'am.
Okay, then we straight away will move to sums. Okay, then. Okay, the same thing. If the line passes through the midpoint of the sides, if these two measures are equal, then what do you say? What is the concept? It is called midpoint theorem, isn't it?
We don't.
Midpoint theorem. Yes or no? If E is a midpoint of AB and F is a midpoint of FC, then AEF is a triangle and ABC is another triangle, isn't it? AE or AB is equal to 2 times of AE, you can say. And AC is equal to 2 times of AF. And you can say EF is equal to 2 times, okay, I'm saying wrong. Another way. Okay, BC is equal to 2 times of EF. This is called the midpoint theorem. Okay. If the line passes through the midpoints of the sides, then that is called, these are the concepts will be applied. This is called midpoint theorem. Okay. Okay, then. Converse of BPT is what? If the lines intersecting either side, the ratios are equal, then the lines must be parallel. That's it. Okay. Okay, then what we do? See, guys, do you have any specific sum wants to be proved, or we can take any sum? Okay. Okay, then. I take some few easy sums and then some tricky sums. Okay. That way we will see. Oh, figure is given. We have to take the figure. Okay. See the figure. In the figure, angle A is equal to angle B. So it is what is given in the sum. Angle A is equal to angle B. D is parallel to AB. DE is parallel to AB. DE is parallel to AB. Prove that AD is equal to, you have to prove AD is equal to BE. What is the idea? Yes, guys, tell me. See, okay, is if you consider triangle ABC. In triangle ABC, angle A is equal to angle B, isn't it? Angle A is equal to angle B. So what kind of triangle is this? Isosceles. So which implies AC is equal to AC is equal to BC, isn't it? Because triangle ABC is an isosceles. Okay. Now next. Then it is given DE is parallel to AB. It is given in the sum. What does it mean? You can apply basic proportionality theorem, isn't it? Because D is parallel to AB by BPT, you can write CD by BA is equal to CE by EB by BPT. You can write by BPT. Okay. Now, what else you can write? So AD, you want to prove AC is equal to BC. So you want to make anything, something may equal to AC. How do, okay, CD I keep as it is, or, okay, let it be CD, I write in terms of AD. How do I write? CD can be written as AC minus AD, yes? AC minus AD. Can you write like this? Instead of CD. Instead of CD, you can write AC minus AD, isn't it, guys? Yes or no? Yes. Okay, denominator I write as it is AD. Similarly, CE, how come you write CE? Very good, very good, very good. By what you can write? Yeah, EB. EB or BE, whatever it is. Okay, now what I do? AC by AD minus AD by AD. Similarly, BC by BE minus BE by BE. Now what you can do? You can cancel this. Yes. So what happens? AC, AD, this is AD. AC by AD minus 1 is equal to BC by BE minus 1, isn't it? Now this 1 can be cancelled, isn't it? Yes. So what happens?
AC by AD.
Very good. So AC by AD is equal to BC by BE. But we know that, what you know that the numerators are equal, isn't it? From 1, yeah, you can, from this, the numerators are equal. Which implies you can simply write AD is equal to BE. What is the reason? AC is equal to BC, isn't it? AC, numerators are matching. Obviously, denominators must be matching, isn't it? Yes or no?
Yes, ma'am.
Hence proved. That is what you want to prove it, right? Hence proved. Make a note of it. Write the sum and write down the solution, okay? See, guys, without understanding, don't even write a single line.
Yes. Finish, ma'am.
Okay. Okay. No issues. Take your time.
Finish, ma'am.
Okay. Mm. Okay. See what is given in the sum. ABCD is a trapezium. Immediately draw a trapezium. Okay. ABCD is a trapezium. Then with AB is parallel to CD. So these two are parallel. E and F are points on non-parallel side, AD and BC respectively. E and F are points on non-parallel sides respectively. Show that EF is parallel to AB. So first you have to connect EF. You have to, so such that EF, it is given in the sum itself, EF is parallel to AB. So this is also parallel to AB. You have to show that AE by ED is equal to BF by FC. How do we prove it? Okay. So where is AE by ED is equal to BF by FC. Okay, fine. So solution in trapezium ABCD, EF is parallel to AB. It is given, isn't it? It is given. And AB is parallel to CD. That is also given. So which implies EF is parallel to CD and AB, isn't it? Got it, guys? Yes. Okay, next. Now what I do, I draw a diagonal. Okay, I draw diagonal and make intersect EF at O. Draw whatever we are introducing, we supposed to mention. Draw DB. It cuts EF at O. Okay. Now, okay. Now I consider the triangle ADB. Okay, in this side, I'm considering this triangle A. I hope all could see my screen, isn't it?
Yes, ma'am.
Okay. Okay, then. So the morning we started this sum. I'll teach once again. I'll start from the beginning. Okay. Yeah. So ABCD is a trapezium. So first you have to write given properly. ABCD is a trapezium. Draw a trapezium. CD where AB and DC are parallel. So these two lines are parallel to each other. E and F are points on non-parallel sides. So E be the point on AD and F be the point on BC. AD and BC respectively. AD, E and F on BC respectively. Such that EF is parallel to AB. So EF is also parallel to AB. Show that AE by ED is equal to BF by FC. Okay. So how do we write the solution? So one thing is very clear. AB is parallel to CD and AB is parallel to EF. So which implies CD must be parallel to EF, isn't it? So all the three lines are parallel to each other. Okay, now what I do, I draw a diagonal BD. Okay, it intersects EF at O. Draw BD, it cuts EF at O. Now what I do, I consider the triangle ABD. Okay, in triangle ABD I consider. Okay. In triangle ABD, we know that EF is parallel to AB. It is given. It is given in the sum, which implies EO. O is point lie on the line, isn't it? EO is also parallel to AB, isn't it, guys? Yes?
Yes, ma'am.
Okay. So, how do you buy BPT? Basic proportionality theorem. You can, what you can write? ED DE by EA is equal to DO by OB, isn't it? Guys?
Yes.
Yes? Okay, I name this as 1. Okay, now I consider the triangle BCD. Okay, consider the triangle BCD. B triangle BCD. In triangle BCD, we know that EF is parallel to CD, isn't it? From this, EF is parallel to CD. So, which implies FO must be parallel to CD, isn't it? By again, you can apply BPT. By BPT, you can write, how do you write? BF by FC is equal to BO by OD. OD. That you name it as 2. Okay. Now you see OB by DO by OB is given. But here BO, I just write upside down this equation. That is not an issue. I just write upside down. So it becomes EA or AE. Same way you can write. That is not an issue. Okay. EA by DE is equal to OB by OD. That way you can write. Now you compare 1 and 2. From 1 and 2, if you see these two are matching, isn't it? OB by OD is matching, isn't it? So from 1 and 2, what you can write? EA by DE is equal to BF by FC, isn't it, guys?
Yes, ma'am.
So that is what you want to prove, right? EA or AE, whatever it is. That is what, hence proved. Make a note of it. Yes.
Yes, ma'am.
Guys, you can understand the steps, right?
Yes, ma'am. Yes, ma'am.
Okay, okay, good.
Finished, ma'am.
Okay. Okay. What is given? In triangle ABC, immediately draw triangle. In triangle A, B, C. D and E are points on sides AB and AC respectively. This is D on AB and and E on point AC respectively, such that BD is equal to CE. BD is equal to CE. BD is equal to CE. It's given. And angle B is equal to angle C. Angle B is equal to angle C. Show that DE is parallel to BC. Okay. So DE, you have to show that DE is parallel to BC. So how do you write the solution? See, one thing is very clear. It is given angle B is equal to angle C. Then what kind of triangle it is? Guys?
Isosceles.
Very good. Which implies triangle ABC is an isosceles. Yeah, isosceles triangle. Therefore, AB must be equal to AC, isn't it? Okay, AB can be written as AD plus DB and AC can be written as AE plus EC. Now, if you see, these two are equal, isn't it? It is given. It is given in the sum. BD is equal to CE. It is given in the sum, isn't it? You can cancel this because you can write it in the bracket. BD is equal to EC. You can cancel, which implies AD is equal to AE. Okay. So therefore, how do you write? Therefore, AD by BD is equal to AE by EC, isn't it? Because AD, numerator are matching. Denominators are matching. So this ratio must be equal, which implies DE must be parallel to BC, isn't it?
Yes, ma'am.
That's it.
Yes,
Hence proved. Okay, that's it. Make a note of it.
Copied, ma'am.
Okay. Here there are only 4. When I could see more than 4, it seems. When it was in the class, somebody hasn't joined, isn't it? Oh. Okay. Okay, now what is given? ABCD is a parallelogram. ABCD is a parallelogram. Okay, then draw a parallelogram. Given a parallelogram. Then P is a point on side BC. P is a point on side BC when it produced meets AB at L. And BC and DP when produced BC and DP. Okay, P is a point on side BC and DP dp when produced. Okay, see, P is a point on the side BC that I marked, and DP when produced, join DP when it produced, and A meets AB. You have to produce AB also. Meets AB at L. Prove that. You have to prove it. Prove that DL by DP equals AL by CD. Okay, how come? What is the idea? Anybody got any idea? Guys, you can tell me, how do we prove it? Is there any idea? Guys, do you have any idea?
No idea, ma'am.
No, ma'am.
Okay, I'll tell you, I'll teach you. Don't worry. Okay. Now, what I do, I take the triangle ADL. Okay, I take the triangle ADL. Okay, now what I'm doing, I'm saying we know that AD is parallel to BC. Why? It is given, isn't it? Because it is a parallelogram. ABCD is a parallelogram. So opposite sides are parallel, isn't it? Guys?
Yes, ma'am.
So which implies AD is parallel to BP, isn't it?
Yes, ma'am.
Okay. So by BPT, what you write? What you can write? LP by PD is equal to LB by BA, isn't it? But yeah, what you want to prove? DL by DP, and that is equal to AL by something is wrong. AL by CD. Okay, I understand. AL by CD, that's fine. No issues. DL. Okay, DL by DP. Okay, now. No issues. Okay, now if you see DL, okay, according to LPDL. Okay. Okay, what I do. Okay, now I add LP by PD, that is equal to LB by BA. Okay, BA, I write that way. Okay, BA. I add one either side. Okay, just I add one either side. So I take LCM. If I take LCM, what happens? PD divided by PD. That is equal to LB plus BA divided by BA. Okay, LP plus PD is what? See the figure and tell me LP plus PD is what? What is it? Ah, LD. So you can write LD by PD. Okay. LB plus BA is what?
LA.
LA divided by BA. Okay. This one, you know that opposite sides are parallel and equal, isn't it? So you can write LD by PD is equal to LA by CD. The reason is AB is equal to CD, isn't it? So instead of, sorry. Okay, instead of AB, you can replace with CD. Instead of AB, you can replace with CD because both are equal, isn't it?
Yes, ma'am.
So that is what you want to prove, hence proved. That's it. Understood, guys?
Yes, ma'am.
Okay, make a note of it. That's it. Guys, see, whenever you want to prove something, do this kind of sum. Don't see the solution. They may be complicated way they would have explained. You write on your own. Okay, give your own explanation. That's really very, very good.
Okay, ma'am.
Okay. Once copied, let me know.
Okay, ma'am.
Okay, okay. Wait a second. Next, what we want to do, that is what I'm. Okay. We will see something else. Okay, guys, anybody, please read and tell me what is given in the sum.
Ma'am, this triangle D
Mm.
is parallel to BC, ma'am.
Mm.
The value of AD is 2 centimeter and value of BD is 2.5 centimeter.
Mm.
AE equal to 3.2 centimeter, DE equal to 4 centimeter, ma'am. We want to find AC and BC.
Guys, can you able to calculate? Yes?
Yes, ma'am.
Please do the calculation and tell me the answer. Do it yourself. Okay, who found the answers?
Ma'am, I found the AC value, ma'am.
Yeah, tell me what is AC?
7.2 centimeter.
Okay. Okay, then BC?
Ma'am, BC 9 centimeter, ma'am.
BC is 9 centimeter. Oh,
Can I
any
know
other?
how to find BC, ma'am?
Okay, same. See, dear, one thing you should know. See, let me check. I'll do the calculation. See, in this one thing you should know. See, if you write AD by DB, that is equal to AE by EC. you can't consider DE and BC because you have taken, there are two triangles. One is ADE, isn't it? Another one is ABC, but you are not considering AB by DB means part of it only you are considering. Isn't it?
Yes, ma'am.
Huh? Okay. So you can't see when you write AD by DB, you can't write DE by BC. Okay. So if you want to write DE by BC, you have to consider the entire triangle. AD by AB, that is equal to AE by AC, that is equal to DE by BC. This is a way you can, when you write this way, you can't consider this measure. When you consider the whole triangle, then only you could find this. Yes, guys, you understood?
Yes, ma'am.
Okay. Now I consider this to find AC. AD is what? 2. Okay. 2 by 2.5, that is equal to 3.5 by EC. So what is EC? EC is equal to 3.2 into 2.5 divided by 2. If you simplify, what it comes? 3.2 into 2.5 divided by 2, it comes 4. EC is 4 centimeter. Then what about AC? EC is 4 centimeters. Somebody said 7.2. Yes, that's correct. Yes. So AC is equal to 7.2 centimeter. That's correct. Okay. Now, next. See, when you want to find BC, it doesn't work. This one doesn't work. So we have to follow this. Okay. So what you do now, you apply this one. AD is what? 2. What is AB? Tell me what is AB? Guys, tell me what is AB?
4.5 centimeter.
Very good. 4.5 centimeter. You no need to take all the thing. You just any take. And D is 4. BC we don't know, isn't it? So BC is equal to 4 times 4.5 divided by 2. If you simplify, it is 9. Oh, somebody gave 9 centimeter, isn't it?
Yes, ma'am.
Very good. So in this itself, you can find AC also. So the same thing, you can find AC also. See, 2 by 4.5. In this, AE is what? 3.2. AC, we don't know. This way also, straight away, you can find AC. You will get the same answer. Okay, divided by 2, you will get what it comes. You will get 7.2. Okay, guys, this way also, you can do the calculation. Okay, make a note of this. Okay, this important point you should know. When you take partially, only you can compare these two ratios. When you take the whole, consider the whole triangle, then only you can write these 3 proportions. Yes, make a note of it.
Copied, ma'am.
Copy,
Okay.
ma'am.
Okay. Okay. Now what is given in the sum? The figure ACB is 90 degree. ACB. So this is 90 degree. This is 90 degree. And CD is perpendicular to AD. CD is perpendicular to AB. So this is also 90 degree. So prove that this one. Okay. So solution, what do we do? What concept we have to apply? Can you guys tell me? See what I do. Pythagoras theorem, that also, but I'm going to use similarity property. Okay, I take the triangles this way. A, D, C. This is, it is given 1 and this is 2. This is 90 degree. And I draw the triangle ACB. C, A, B. Okay. Now if you see, this is at C, it is 90 degree. This is 1. Okay. By AA. Okay. By AA criteria, these two triangles are similar, isn't it? There is a
Yes,
criteria. See, two
Yes, ma'am.
angles are equal. Obviously, the third angle must be equal, isn't it?
Yes,
This must be 2, isn't it? Guys, by AA triangle ACD is similar to triangle ABC.
ABC.
Yes, from this itself, you can write AC by AB is equal to CD by
BC.
BC. That is equal to AD by AC. Very good. So now you write AC by AB, that is equal to CD by
BC.
E, that is equal to AD by AC. Okay. Now what we want CD square, isn't it? So how do we do that? Wait. Okay. Wait one second. Am I right? And the order is very, very important. A is the angle A is matching with the angle. See, I made mistake here. Have you noticed? I made mistake. No. Wait. Let me check once again. No. I have written A angle A is matching with angle A. Angle C is matching with angle B. Angle D is matching. Yes, I'm correct. Okay. That's correct. Once again, what I could do. How do we compare BD, AD? Where is BD? There is no BD. Okay. AC, AD, BC. Okay, let me check what we could do. Okay, actually CD square, how do we write? CD square can be written as AC square minus AD square, but we can make it easy. Let me, wait, give me a second. Yeah, I got it. Yes. Okay, I'll explain once again. Wait, guys, I'll explain. Okay, what I do, I take these two. So this one, how do you rewrite? AC by AB is equal to AD by AC. Now you cross multiply. AC square is equal to AB times AD. Okay, let it be. Now you consider this triangle. This is a right angle triangle, isn't it? So you can apply Pythagoras theorem. In Pythagoras theorem, what is AC square? AC square is equal to AD square plus CD square, isn't it?
Yes, ma'am.
So, yes. So we want CD square. We want CD square to be found. We want CD square. So I make CD square as subject. CD square is equal to AC square minus AD square. Okay. So in the place of AC square, I replace with this. So instead of AC square, I write AB into AD minus AD square. See, in these two, AD is common. You can take AD commonly out. If you take AD out, AB minus AD. Okay, AB minus AD is what? Guys, AB
Pardon?
minus, huh?
Once again, ma'am.
AB minus AD is what? This is AB, this is AB, and this is AD.
BD, ma'am.
BD. That is what you want to prove, isn't it? That
Yes,
is what you want to prove. Hence proved. That's it. Okay. Make a note of it, guys.
Yes, ma'am.
Okay.
Copied, ma'am.
Okay. Okay. So what is given in the sum? Prove that the line segments joining the midpoints of the sides of the triangle form 4 triangles, each of which is similar to the original triangle. Let's check. So there is a triangle. First you draw a triangle. There is a triangle. And midpoints. I name the vertices as ABC. And the midpoints is P, Q, R. So one thing is very clear. These two measures are equal because P is a midpoint. These two measures are equal because Q is a midpoint. And these two measures are equal because R is a midpoint. Now you join the lines. Okay. Now you have to prove that all the triangles are, see, each of which is similar to the original triangle. The triangles each, there are 4 triangles, isn't it? In one triangle, we made into 4 triangles. These 4 triangles are similar to each other. That is what we want to prove. Okay. So how do we prove it? See, one thing is very clear. If you see solution, P and Q are the midpoints, isn't it? Midpoints of AC and AB. Therefore, AP by PC is equal to AQ by QB, isn't it? Guys? Because
Yes,
by midpoint theorem, you can say you can write, yeah, this ratio must be, because this is a 1 by 2, no, 1, it comes 1, both are equal, isn't it? This you could cancel, this also you could cancel. Guys, can you understand?
yes.
So therefore, you can say PQ is parallel to CB, isn't it? These two lines are parallel, isn't it?
Yes, ma'am.
Okay, similarly, you can write similarly. PR is parallel to RQ and PR is parallel to AB. Sorry, not RQ. PR is parallel to AB and RQ is parallel to what? Guys? Tell me. See this line is parallel to this line because this ratio is equal. AP by PC is equal to AQ by QB. Similarly, this one, PR is parallel to AB. The reason is what? The reason is these two ratios, this by this ratio. CP by PA
Ma'am,
is equal to, yes,
RQ is parallel to CP, ma'am.
where RQ is parallel to?
CP.
No. Yeah, CA. You can write CA better. Okay, that way. CA, the entire side. So which implies, so PQ is parallel to CB means you can write this way. What? Triangle APQ is similar to triangle ABC. ACB, not AB. Okay, you can write this way. Okay, that is not an issue. You can write ABC. No problem. Similarly, this case you can write triangle CPR. CPR is similar to triangle ABC. Similarly, what? Triangle BQR is similar to triangle ABC, isn't it? Guys?
Yes, ma'am.
So that is what? So each of the four triangles, and what about the middle? So three triangles we proved. This is similar, we proved. But what about the center triangle? What's the idea? See, this form of parallelogram. Okay. This form of these opposite sides are parallel, isn't it? These form a parallelogram. This is a parallelogram. Diagonal bisects two congruent triangles, isn't it? So these two are equal. So this is also similar. That's it. PQN, PQBR. PQ is parallel to BC, which implies PQ is parallel to BR. Okay. Similarly, RP is parallel to AB, which implies RP is parallel to BQ. Okay. So RQ is the diagonal. So we already learned diagonal makes two congruent triangles, isn't it? So therefore, PQBR is a parallelogram and the diagonal RQ makes two congruent triangles. Therefore, all four triangles are similar to triangle ABC. That's it. Guys, can you understand or do I want to explain once again?
Understand.
Okay, you make a note of it. Okay, we will do some other sum.
Okay, ma'am.
Okay.
Copied, ma'am.
Okay. Now what is given in the sum in the given figure? AD is perpendicular to BC. It is 90 degree. And BD by DA. BD by DA is equal to DA by DC. Okay, that is given. Prove the triangle ABC is a right angle triangle. Okay, let's see. Okay, so I draw two separate triangles. Okay. BD, A, here it is 90 degree. Okay. And another triangle. DA, DA by DC. Okay. Another triangle. Okay. And this is A, this is DC. Okay, it is given BD by DA equals DA by DC. What I do, I interchange. Oh, DA. Okay, okay. So BD, DA by BD by DA and DA by DC. That means what? That means these two triangles are similar, isn't it? If
Yes,
this
ma'am.
comes, these two triangles are similar, which implies triangle BDA is similar to triangle C. No. See, that same way you have to start. I started from B. BD. BDA means you started from A. You're supposed to. Can you understand, guys? A,
Yes,
D,
ma'am.
C. So one thing is very clear. See, if two triangles are similar, the corresponding angles are equal, isn't it? So which implies angle B is equal to angle A, angle D is equal to angle D, angle A is equal to angle C. Isn't it? Okay. So you come to this one. So this is equal to what? This angle is equal to this angle. I name it as 1. Okay, this angle is equal to, I name it as 2. This angle is equal to 2. Okay, one thing is very clear. This is 90 degree. What about angle 1 plus angle 2? That also must be 90 degree, right? If you take any triangle, if I take in any triangle, in triangle ABD, if you take angle 1 plus angle 2 plus 90 degree must be equal to 180 degree, isn't it? So angle 1 plus angle 2 must be 90 degree, correct?
Yes, ma'am.
So according to this, what? This is 2. This is 2. This is 1. So from the figure, you can, okay, you can write this way, not this way. You can write this way. Angle BAC is equal to angle BAD plus angle CAD, isn't it, guys? See, B, angle ABC. Sorry, angle BAC. Angle BAC equals, angle BAC equals angle BAD plus angle CAD, correct? So BAD is equal to angle 2. This is angle 1. What it is? 90 degree. So which implies triangle ABC is a right angled triangle. That's it. Hence proved. Guys, you got it?
Yes, ma'am.
Is there any step you couldn't get it? புரிஞ்சுதா இல்லையா?
Understood, ma'am.
Okay, make a note of it. This chapter fully all are proving sums. It will be like this only. So you have to work out, guys. If you work out more number of sums, you will be familiar how to prove each and every kind of sum. That's it.
Okay, ma'am.
Okay.
Okay, ma'am.
Let me see some different sum. So what is given in the sum? There is a triangle ABC and B is 90 degrees. So it is a right angle triangle, isn't it? So it is a right angle triangle. A, B is 90 degree. Okay. And D is the midpoint of BC. D is a midpoint. So these two measures are equal. BD is equal to CD. And you have to prove it. You have to prove that AC square is equal to AD square plus 3 CD square. Okay. Okay, AD square, you have to join then AD square. So in this one, I'll give you idea. You try on your own. Okay, guys, and you tell me the steps. If you could prove and tell me the steps. You just apply Pythagoras theorem. There are two triangles, isn't it? One is one right angle triangle is ABD is one right angle triangle. Other one is what? ABC is another one triangle. Okay, you just apply Pythagoras concept and prove this is a you have to prove this. Try yourself. If you don't get it, I'll tell you. Yes, start. I'm also writing. Let's check whether you could prove it or not. Okay, I'm also working on it. I do it in my notebook. Guys, have you got the idea or shall I do the sum?
Couldn't figure out the idea, ma'am.
Okay. I'll do it. Don't worry. I'll do the sum. See, I take RHS. RHS means right hand side. Okay. I take RHS side. AD square plus 3 CD square. Okay. AD, see, we want to convert everything into AC. Okay. Okay, so I want AB square plus BC. Okay, I don't want to confuse you. Consider this triangle. AD square is hypotenuse. So you can, instead of AD square, you can write AB square plus BD square. Isn't it, guys?
Okay, ma'am.
Okay, then I take 3 outside. Instead of CD, I write BC minus BD. Yes? Can I write like this?
Okay,
Oh,
ma'am.
no need. I write it this way. This will be easier. See what I do. CD is half of BC, isn't it? Because D is midpoint, CD is half of BC. So I can write BC by 2 the whole square, isn't it, guys?
Yes, ma'am.
Yes, ma'am.
Okay. Now what I do, I write AB square as it is. And BD also can be written as BD is also half of BC, isn't it? Because D is midpoint. So I write BC by 2 the whole square. This is also plus 3 BC by 2 the whole square. Now 1 BC by 2 the whole square. This is 3 BC by 2 the whole square. So you could write 4 BC by 2 the whole square. Now what I do is square and 4 BC square divided by 4, isn't it? Guys, can you understand the step?
Yes, ma'am. Yes, ma'am.
So what it comes? If you cancel 4, what it comes? AB square
AB square
plus
plus BC square.
what it is? AB square plus AC square. AB square plus AC square is what?
AC square.
AC square. That is what this LHS, isn't it?
Hence, no, this, ma'am.
Yeah, LHS. So hence proved. Okay.
Yes, ma'am.
Okay, make a note of it, guys. Yeah. See, guys, try doing rest of the sums. Okay. All a similar kind. Okay. You by doing the sum more and more only, you will have more ideas. You know to solve. Okay. Just so you have to work out more and more sums. That's it.
Okay, ma'am.
Okay. Take a note of it.